The program is powered by Automation Trader, your trusted supplier of industrial automation components and solutions. New, used, refurbished parts, or maybe those discontinued from production. Contact us. We'll find a solution.
Hi again. Years ago, we used to use a big heavy transformers. Here's a very large 3-phase transformer, and this used to be the main method of changing voltages days. Because the semiconductors become really cheap, we're using switching power supplies. Much smaller, much lighter. Despite more complex structure, the switching power supplies are much cheaper. It's much easier to regulate the output voltage and the efficiency is much higher. And also because PFC, they have better power factor. But let's start from the beginning. Here is the same switching power supply without cover, and shortly I will explain how it works. Here's the input voltage, 230 volts. Next is a fuse, thermistor. Then there is a rectifying bridge. After the bridge, we're getting around 330 volts DC. Here we have some smoothing capacitors, and next the voltage goes on the transistor. This transistor is switching on the transformer with frequency of tens of thousands times per second. This transformer is doing exactly the same thing what this old-fashioned transformer is doing. So it's changing the voltage. But this transformer is working with frequency of 50 Hz, so 50 times per second, and the small one works with tens of thousands times per second. And the small ones works with tens of thousands Hertz, so that's why they can be so small. This large transformer have a bit smaller power than the little ones on the PCB. After that transformer is a rectifying diode, and the AC is changed to DC again. This diode is behind this aluminum plate, what is a radiator at the same time. And again the voltage goes on the smoothing capacitors, and it goes straight to the output. The main advantage of the SPS is the constantly monitoring of the output voltage. So if you have a variable load and the load is changing from very low current to almost maximum what we can get from this power supply, the voltage will constantly stay on the same level. This is possible because we have a feedback from the output voltage, so the signal goes through the octocoupler, what is isolating the primary side of the transformer from the secondary. So the signal goes to the control circuit, and the circuit is controlling the pulse width given to the transistor. And on the end we get in the required voltage. And the next advantage is a possibility of installing power factor correction. About the power factor correction we will talk in the future films. For now I will just say a few words what is the power factor correction. In almost all devices we get in the reactive power. In transformers this value is quite high, and this is also one of the biggest defects of the transformers. The reactive power is the power that flows from the device back to the supplier, so basically it's wasted. In the houses we don't have to worry about it because our meters doesn't count the reactive power, but big workshops and factories do pay for it. To reduce the reactive power and cut the electric bills, we're using power factor correction. In switching power supplies with power higher than 70 watts, the manufacturers must install active power factor correction. But on smallers like this one, usually in use is passive power factor correction. In big factories where many induction motors works in the same time, and because we may have capacitive loads and inductive loads, and electric motors are inductive loads, we can get two different reactive powers, and these two powers eliminating each other. So if you have many induction motors in one place, then the factories are using big capacitors like this one to get a better power factor. That's everything for today, and see you in the next episodes. Thank you.